Hi, and welcome to my second power session on systems of equations. We're doing part 2 elimination power session with Mama L. So what you'll learn with this session is how to solve a system of equations using elimination with and without multiplication. So as a reminder, we have 3 ways to solve a system of equations. I've already taught you substitution, and today I'm teaching elimination. Graphing will be coming up next. All right, first the thing you have to do, remember that you were dealing with 2 equations when doing systems of equations. And the first thing that you need to do is rearrange one of your equations so that the same stuff is on top of each other. So you want to get your x's lined up and your y's lined up, your equal signs, and then the plain old numbers. Those are called your constants, all right? So if our 2 original equations were these, right here and right here, they're not lined up, right? We don't have our x's, our y's, our equal signs, and our constants. So we're going to take, I tend to like things in alphabetical order. I like to get my x's and then my y's and then my constants at the end after my equal sign. So I'm going to rearrange this one. The other one, notice that one stays the same. Okay, but this one, I'm going to have to take away 6 from both sides, canceling that out. That gets my y alone. And then I've got my, my 5 x's on the right side. I've got to subtract those so that I can move them over to my left side. So it cancels them out over here, but it gets them on the left. So I'm going to put my x's first. When you subtract 5x's, it's like adding a negative 5x. So I'm going to put that in front. Negative 5x equals positive y, or excuse me, plus positive y equals negative 6. So now we have everything nice and lined up for continuing to solve. Second thing you need to do is decide, is it easier to add or subtract your equations? Pause, right? How do you do that? How would you know to do that, right? Well, remember, the point is to get rid of or eliminate a variable. We don't want 2 x's and 2 y's. We want just x's or just y's. And it actually doesn't matter which one you pick, but one of them's got to go. So when you have equations with a system of equations, take a look here, okay? This is what we've got. We've got 2 y's. They perfectly match. That's great. If you have a match, you're going to subtract one equation from the other. If you have opposites, like if I had a positive and a negative y, I would add them. So let's think of it with something realistic, like a dollar, okay? If I had a positive dollar and a negative dollar, I would add them together to cancel out, and they would no longer exist, right? If I had a positive dollar and a positive dollar, well, I would subtract one from the other, and that's how I wipe them out, and they wouldn't exist either. Okay, so instead of thinking about dollars, think about your x's or your y's. If you want to think about something concrete, in class I typically talk about things like X-Men or yo-yos or yaks or xylophones, because I think it helps my students understand that a little bit better. So again, if you have opposites, you want to combine them and add your equations. If you have a match, you're going to subtract one equation from the other. So what does that look like, right? Well, here's what it would look like. If I were to add them, if I made the wrong choice, okay, and I wanted to add them, I would have 1x and negative 5x. That would give me negative 4x, nothing wrong there. But then I would have y plus y, or a yo-yo plus a yo-yo. Well, that's 2 yo-yos. 3 plus negative 6 is negative 3. I didn't get rid of any of my variables. They're still there. So that kind of defeated the point, right? If I subtract, here's what happens. I'm subtracting here, okay? So 1x minus a negative 5x. So that's what this looks like. 1 minus negative 5. And I tell my students, I teach them, keep that sign, change that sign, change that sign. That's actually 6x. And then if I have y minus y, and it's really important to put that subtraction sign out there, because if you don't put it there, those negatives are going to throw you off. Y minus y is nothing. There we go. That's what we wanted, to cancel it out and eliminate it. Finally, 3 minus negative 6, if you want to write it off to the side, remember, keep, change, change, just becomes 3 plus 6. So we continue on. Third, add or subtract your equations so that you are wiping out or eliminating that variable, right? So we got to that point where we need to go ahead and divide by 6 to get our x all by itself. So I'm going to divide each side by 6, and x will equal 3 halves. 3 halves, if you put it in decimal form, is going to be 1.5. Not quite done yet though, right? We want to plug that variable into either equation to solve for the other variable. So we figured out that x equals 1.5. Which equation would you do, right? Pick the easier one. Make your life easier if you could ever do that. Well, if x is 1.5, 1.5 plus w equals 3. That one looks a little bit easier to me. Subtract away the 1.5 because it's positive, so we're going to take it away, canceling it out, and y equals also, ironically, 1.5. So your answer is x equals 1.5, y equals 1.5. Okay, so it seems long now, but once you get more practice, it's not going to be as long. Okay, let's look at one where we have to use multiplication. Okay, 6x plus y equals 18, 2x plus 4y equals 28. Well, first rearrange your equations so that the same stuff is on top of each other like before. We've got our x's, our y's, our equal signs, and our constants. A new step. This is just one extra step we're going to slip in there. We're going to look at our equations the way they were, here and here. Now, we don't have matching amounts of x's or y's, so we're going to decide, we're going to manipulate one of these equations so that it works for us. We could do it lots of different ways. Sometimes you can multiply both equations, but I usually try and find the shortest possible way to do this. Because, right, who wants to spend that much time doing math when they don't have to do a bunch of extra math, right? So I see that if I multiplied this y by 4, I would get a matching 4y. See, that's what I'm going for. So 6x times 4 is 24x, 4 times y is 4y, and then 18 times 4 is 72. So there's a new answer. Second, decide if it's easier to add or subtract your equations. You probably already figured this out because you already manipulated the equation in the way that you wanted. So if I have two positives, what do we do? Add or subtract? Two positives. We're going to subtract, right? 24 minus 2 is 22 of something. 4y minus 4y's, 4 yo-yos, take away 4 yo-yos is no yo-yos, yes. And finally, 72 minus 28 is 44. So go ahead, third is to add or subtract your equations. So in this case, we subtracted to eliminate those 4 y's. Finally, you just have to finish up and solve for your variable, and x equals 2. So now that we know that x is 2, pick the easier equation, either one, to go ahead and solve for. So I'm going to go ahead and plug it in, probably the one on the left. 6 times 2 plus y equals 18. 12 plus y equals 18. Take away 12 from both sides. Y equals 6. So x was 2, y was 6. Let's try this next one. 3a plus b equals 37, and a minus b equals 3. I don't have to do any rearranging, so that first step is taken care of. Then I have to decide, is it easier to add or subtract? Well, I've got opposites right here, one on top of the other. So I'm going to add opposites. When you add opposites, they cancel out. So I have 3 apples and an apple, so that's 4 apples. And 37 plus 3 is 40. Divide away your 4's, and a equals 10. Not too bad, right? I can plug that into either equation. Let's go ahead and plug it into the easier one on the right. A minus b was 3. So if a is 10, what do I take away to get 3? 7, right? If you weren't sure, you could take away 10 from both sides. The opposite of b equals negative 7, and divide by negative 1 to get b equals a positive 7. But most of you would have seen pretty quickly that 10 minus 7 equals 3. All right, let's try this one. 6r minus 4l equals 64, and then l minus 2r equals negative 22. I'm going to line everything up, okay? Let's put our positive l right here. So this positive l goes under my 4l, negative 2r's, and then negative 22. I could do a couple things. I could multiply the bottom by 3. In fact, let's go ahead and do that. If I multiply each section by 3, and again, there's more than one way to do this, I get negative 6r, I get positive 3l, and I get negative 66. Let's put that right up next to our other one. All right, I see I have opposites, right? That's what I was going for. Do we add or subtract opposites? We add them. Adding opposites cancels them out. So then I have 3 Legos, and I'm adding a -4 Legos. That ends up being a -1L or negative L. And -66 plus 64 is -2. If I divide away that -1, L equals 2. I can plug it back into either one of them. If L is 2, I'll put in that right side one. 2 minus 2R equals -22. Let's go ahead and take away that 2 from both sides. That negative stays with my 2R. That's -24. Divide by -2 on both sides, and R equals 12. There are my answers, 2 and 12. The steps that we followed were a little bit complicated, but I wrote them all out for you, okay? First, rearrange each one of your equations so that the same stuff is lined up. Second, multiply if you need to. That's not always the case, but sometimes you need to multiply one of them so that you have either opposites or matching amounts of variables. Next thing is to decide, is it easier to add or subtract your equations? And then do that. Add or subtract them so that you eliminate or wipe out your variable. Fourth, finish up by solving for the variable. And fifth, plug it in to either equation and solve for the other variable. All right, that's the end of today's session. Thanks for watching, and I've got one more session that's on graphing when you're doing systems of linear equations. I hope you can watch it. Thanks.